A powerful reason that the Big Bang theory is accepted by most astronomers and astrophysicists is that it provides a connection between current particle physics and cosmology. In everyday world, we routinely come into contact with two forces, the force of gravity that keeps us planted on the ground and the force of electromagnetism that runs our machine and keeps solids from falling apart. But in the realm of atom, there are two other forces. There is the force that keeps the particles of an atomic nucleus together, called the weak force, even though it is able to overcome the repulsive electrical force that the electrically positive protons in the nucleus exert on one another. Far stronger is the so-called strong force, which allows the particle or quarks that make up the proton and neutrons in the nucleus to adhere together. There are then four forces we know about in nature. Throughout the history of science, people have tried to show that the universe is governed by a simple scheme, with one force governing all of nature rather than four. So, just as electricity and magnetism were shown in the 19th century to be two forms of a single force, science has looked favorably at any attempt to unify the four forces of nature into a single force, a grand unified force. Much of the theoretical work in modern physics has been to derive mathematically and experimentally what that force is like. Perhaps we have learned that orthodoxies have a way of not remaining orthodoxies for very long. For instance, recent images from a telescope 40 times sharper than those obtained by Cobb showed that the universe was flat, not curved as previously believed.